Hi, this is Mrs. Swigart, and today we're going to be talking about weighted averages. And this lesson is a little bit complicated, and it may be a little bit longer than some of the other lessons. Okay, it's lesson 2.9. Now, we're going to start with a table, and sometimes tables help us organize our thoughts. And weighted averages is one of those places where a table is really useful. Okay, we're going to list the number of pounds and the price per pound of the chocolate chip, the white chocolate, and the mixture. Delectable Cookie Company is selling chocolate chip cookies for $6.95 per pound. So the number of pounds we don't know yet, but we do know the price is $6.95. How many pounds of chocolate chip cookies would be mixed with 4 pounds of white chocolate chip cookies to get $6.75? Well, we don't know how many chocolate chip, but we do know how many white. And so on the bottom row, it's the chocolate chip plus the white. That's why we have an equation here. Now, we also have $6.95 for the chocolate chip. We do know the white is $5.95, and we know we want on our final mixture, we want to be able to sell it for $6.75 per pound. So that's why that is in the final box. So let's multiply across. W times $6.95 gives me $6.95 in W. 4 times $5.95 gives me this, and then again we multiply across and get this. So in order to find out how many pounds, we would add the first two and make it equal to the last one. So our equation would look like this. You take the end boxes, and the first two you add, the second one the last one is what it's all equal to. Now this is if you're adding things together. You can also subtract things, so sometimes there'll be a subtraction instead of an add. Okay, first off, let's multiply this, and then let's distribute down here. So this becomes $23.80, and then this gets distributed. Now we want all the W's on the same side and all the constants on the same side. So I decided to move the W first. So I moved $6.75. I took it the other side and subtracted. Yeah, I know, I did it on both sides, but that was the way the problem was written last year. It's still the same. Remember, we proved that in the very first lesson that we did on equations. Now, let's put our W's together, and we end up with 0.2. But we still have to move $23.80 to the other side. So it's add, so we're going to subtract it. And then we're going to put a decimal behind our 27 and subtract. We're going to get 3.2. And now we're going to divide by 0.2. And when we do, we have to add. We find out that we need 16 pounds of chocolate chip cookies, or chocolate chips, to make this work out the way it's supposed to. Okay, this is a problem. If we hadn't had the chart, we wouldn't have been able to do it. Now this is one of those also we need a little more help. So let's look at one more. Okay, the tea company sells a blend of tea for $25 per pound. To make blueberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make blackberry tea? Well, let's start with all the numbers of units. So we know we have on the dried blackberries, we have 5 pounds. That's in the final question statement, isn't it? We're looking for how much black tea to add. And so 5 times W, or 5 plus W, I'm sorry, to find the total amount of pounds that would make up the mixture. Now, the dried blackberries are $10.50, and the black tea is $35 a pound. And so we can add those to, or but we also know that our final cost for our tea, we want it to be $25. Okay, and where did we get that? At the beginning of our statement. Okay, they're selling it for $25 for the blackberry tea. So let's go this way, multiply. So we have 5 times $10.50. We have 35 times W. And then we have 25 times 5 plus W. We're going to take the first two and add them equals the last one to set up our equation. Well, our first thing is to multiply and to distribute. So that's what we did on this row. This becomes $52.05, 52.5, and then 25 times 5 is 125, and 25 times W is 25W. Now we need our W's together and our constants together. So we're going to move the W first, and we want to move it so that it's on the positive side. So we're going to have 35W minus 25W. Now, the other thing is we've got to move that 52.5. So we're going to move it on the next row. And we're going to end up subtracting it from both sides. So we end up putting our constants together. We get 72.5. We're going to divide by 10. And we're going to get $7.25, which is the pounds that we need for our black tea to be right. So the table is very helpful. It's just knowing how to plug the numbers into the table. Okay, one more time. Mrs. Matthew made 16 cups of punch that were 3% pineapple juice. She also has a punch that's 33% pineapple juice. How many cups of the 33% punch will she need to add to the 3% punch to obtain a punch that's 20% pineapple juice? So we have 3% punch, we have 33% punch, and then we have 20% punch, which is our final goal. The amount of punch of each one, of the 3%, we need 16. Of the 33, we don't know. That's what we're looking for. And then our final punch, we know, is 16 cups at 20%. Okay, so 16 plus X. I'm sorry, I said that wrong. Okay, the amount of pineapple juice would be 3%. We changed that to decimal times 16. We wrote it here. 33 times X would be 0.33 times X. And then 20% times this would look like this. We're going to add these two equal to the last. So here's our equation just like we did before. We're going to multiply, and that's why we get 0.48, and then 0.20 times each one of the terms gives us this. We want our x's on the same side, so we're going to subtract 0.20 from this side. We're going to put our constants together, our x's together on our next row, and so we get 0.13. We need to move this constant to the other side. So we're going to subtract it. And then our final step is we're going to divide by 0.13. And so when we do that, we get our answer is 20.9. It's got a lot longer answer, but this is really all we need. Okay, notice we have the little curved lines. It means that it's approximate. And since we put all the decimal points out to umpteenth places, then that is appropriate. Okay, it took Travis and Tony 40 minutes to skate 5 miles. The return trip took them 30. What is their average speed? Well, that is rate equals distance times time. Well, we want the rate, so we're going to put the distance over the time. And on the first one, it would be 5 miles over 0.667 out of the hour, because 40 minutes over 60 minutes is where I get this decimal right here. Okay, because we want to know how much of the hour is used. Okay, Then we've got to do the return trip. Same thing. 5 miles over. Now, 30 over 60 would give me 0.5 of the hour, or half of the hour. And if we did this, we'd find out it was 10 miles. Okay? So we just divide the 0.667 into 5 and then 0.5 into 5 to get these two numbers. Now, what is their average speed? We would add those two numbers and then divide by 2. So here's our first rate times our time, our second rate times our time, the time going plus for both of them so that we can get that rate. So now we work this problem. Okay, this is a hard one. This one's one you're going to want to have an example, especially with this particular problem. Okay, because they are difficult. Okay. Okay, this is the last one we're going to do because this video is already long enough. Two trains are 500 miles apart heading towards each other on parallel tracks. Train A is traveling east at 35 miles an hour, while train B is traveling west at 45 miles per hour. When will the trains pass each other? So here's what we're talking about. Here's a diagram. Sometimes it's helpful to have a picture so we can figure out what we're talking about. And here's our chart. We have a rate of 35 miles an hour and a time, and there's our rate for train B and a time. Remember, distance equals rate times time, so that's why this is 35t and 45t. And we want to know they're traveling the same distance. So we're going to add these, and it should equal 550 miles. Now, when we add, we get 80. Now we're going to divide by 80. So our answer is 6.875. Okay. And that's it for today. We'll look at these maybe tomorrow. We're done. Good luck.